Hello, my name is Ioana Kulik, and in this video we continue the series of applications for our intelligent home. And now we will focus on the kitchen and developing a smart fire and smoke detector and control system that we want to prevent such things from happening. So as an outline, we will look into the electronics that we need to build the intelligent control system for our kitchen. Then we will build an application that detects if there is smoke in the kitchen and acts accordingly. Then it detects if there is fire and does the necessary actions. And finally, we will take into account both fire and smoke and act as needed. Regarding the electronics, we have a flame sensor that is capable to detect fire. We have a gas sensor that we use to detect smoke. We have a servo that is connected to the kitchen's window, and we can use it to open and close the window. And we have a buzzer that we use as an alarm. The gas sensor is an analog one, and it is connected to GPIO 26 of the Raspberry Pi. The flame sensor is a digital sensor. It acts as the peer sensor that we used before. It gives us a 1 in case it detects fire, or a 0 reading in case there is no fire detected. The buzzer is connected on the PWM pin GPIO 0, and the kitchen servo is connected to GPIO 4, and we can control it, of course, using the servo blocks. Now, regarding the smoke detection application, we just want to detect if there is smoke present, and if so, we want to start the alarm. For this, we first initialize the PWM pin for the buzzer, and we initialize our analog input pin, pin 26. And we have two functions. We have a function called off that just sets the duty cycle of the buzzer to 0. And we have another function that's called alarm that basically does what we have done in a previous video when we wanted to implement an alarm system. It counts from 0 to the maximum duty cycles in increments of 1,000 and sets the duty cycle accordingly. And after it reaches the maximum, it decreases by 1,000 up until it reaches 0. And for each of the values that we set for the duty cycle, we wait 10 milliseconds. Now, in our while block, the main application, we want to read the values coming from the gas sensor. And if these are above 500, it means that there's smoke present. So if there's smoke present, we call the alarm. Otherwise, we just turn it off and we keep on reading values coming from the sensor. For the next application, we want to detect fire. And in this case, which is more crucial, we want to make sure that once the alarm is activated, it keeps on ringing for at least 10 seconds. So we have the same, we initialize the buzzer pins, and we have the off and the alarm functions for them. And we have the digital input pin 1 for the fire sensor. Now, inside the while loop, we keep on reading values coming from the fire sensor. But if one of these values equals to 1, so some sort of fire was detected, we call the alarm, but this time we call the functions 10 times. This is because we want to make sure that it calls for at least 10 seconds. If you make the computations regarding how many iterations are done with our 2 count blocks, and the fact that each block waits for 10 milliseconds for each iteration, it gives us a value of around 10 times that we need to call the alarm to reach 10 seconds. And finally, the final application wants to combine both sensor and both flame and gas sensors, to detect if there's both fire and smoke. And now we will also control the windows. So in this case, we want to make sure that if there's fire detected, the alarm rings for at least 10 seconds, no matter what, and the windows are closed. This is important in case there's fire detected. However, if there's smoke and no fire, we can open the windows and we will call the alarm as long as there's smoke detected. We don't need to set the 10 seconds thresholds. So we do the following. We keep on reading if there's smoke or if there's fire. And the most important that we need to verify first is fire. Because no matter what, even if there's fire or even if there's smoke, we will call the alarm. So we need to check if there's fire. And if there is fire present, no matter if there is smoke or not, in either cases, we need to have the windows closed, and we need to have the alarm ringing for at least 10 seconds. Next, if there's no fire, we need to check if there's smoke. So on the else if branch, we ensure there's smoke, but that means that if we reach that point in our application, there is no fire. In this case, we can open the windows and we just call the alarm once. Basically, we call the alarm function just once. And on the else branch, the third one, it means there's no fire, there's no smoke. We can just turn off the alarm and we will leave the windows in the initial positions. We don't change the position the windows previously had. So in this video, we implemented an intelligent fire and smoke detector system that allows us to control windows and an alarm in case there's fire or smoke present in our kitchen. Thank you.